I'd like to do an example of resonance and show how formal charge determines the preferred structure from a set of resonance structures. Resonance is where there's more than one valid way to draw a Lewis structure for a single compound. Amongst those resonance structures, there might be a preferred structure, and the way we figure out which one of those is preferred is by uh, figuring out the formal charge on each atom in that compound. The way you calculate formal charge on an atom is you take the group number minus the dashes that are connected to it minus the dots that are associated with it. Really what we're doing, I like group minus dashes minus dots as an easy way to remember. What we're really doing is we're taking a look at the valence electrons minus the bonding pairs minus the lone pair electrons. But again, I really prefer this right here. I think it's a lot easier to remember. So let's go ahead and take a look at an example here. Let's do carbon dioxide, CO2. Again, to draw the Lewis structure, what I'm going to do is I'm going to determine the number of valence electrons available. So that's going to be uh, 4 for carbon plus 2 times 6 for oxygen, grand total of 16 valence electrons. I'm going to go ahead and draw my skeletal structure, carbon in the middle, oxygen on each side. I'm going to go ahead and connect the dash, complete my octets, and count up used. I've used 20 electrons here. I only had 16 available, so what I need to do is I need to start adding some multiple bonds. So I'm going to go ahead and erase 2 electrons off the central and 2 electrons off one of the oxygens, and I'm going to go ahead and connect another bond to that. Now at this point, what I'd like to do is make a couple of copies of this because I've got a few options and I want to show you what's going to happen here. So let me copy this and make one more copy here. Oops. All right, so I've got several copies of this. Now, at this point, what I can do is I've still used, well, I've got this down to 18 electrons at the point, right? Let's see here. 2, 4, 6, 8, 10, 12, 14, 16, 18. Yes, I've got this down to 18 used, and I only had 16 available. So what I'm going to do is I'm going to go ahead and I'm going to take 2 more off the central. I'm going to take 2 more off of this oxygen and put in yet another bond. So I've got a triple bond, which now takes this down to 16 electrons used. All right, so this is where I started at with my 16 electrons. Why couldn't I have just, instead of taking off 2 off the central and 2 off of this oxygen, why couldn't I have just taken 2 off of this carbon and 2 off of this oxygen and added in a double bond here? That still takes me down to 16 used. And what I could have done is originally, rather than double bond here, I could have bonded on the other side, which would have taken me down to 18, and then went ahead and triple bonded on this side. Now that's very similar to this, but it's not the same because this is like oxygen number 1, if you could number them. This would be like oxygen 1, and this is oxygen 2. So in this case, I've got a single bond between oxygen 1 and carbon. Over here, I would have a triple bond between oxygen 1 and carbon. So they are different. All right, so I've got 3 structures, and what I need to determine is if one of these is a preferred structure. So what I'm going to do is for each one of these atoms is I'm going to calculate the formal charge. So let's go ahead and do that. On this first oxygen, what I'm going to do is go to the group number, which is 6, minus my number of dashes. I've only got 1 dash, minus my number of oxygens, or excuse me, my number of dots, which is 6, 2, 4, 6. So that leaves me with a formal charge on this oxygen of -1. So that's a -1 on this one. The carbon is going to be the group minus the number of dashes minus the number of dots, which gives me a formal charge of 0. And then over here, I've got group minus dashes minus dots, which gives me a formal charge of +1 on this oxygen. Formal charge of +1 on this oxygen. My preferred structure, let's go ahead and state this now. The preferred structure is the one with the most formal charges equal to 0. So we're going to go ahead and do the same thing here. We're going to figure out formal charges. Again, I've got group number, which is 6, minus dashes, which is 2, minus dots, which is 4, which gives me a formal charge on this particular oxygen of 0. I've got carbon, which is going to be 4 minus 0, which is also going to be 0. And then I've got this oxygen, which is the same as the other one. It's got 2 dashes and 4 dots, so I'm not going to recalculate. I know it's 0. It's identical to this side. This one I don't have to calculate because I pretty much calculated it over here. This is going to be -1, this is going to be 0, and that triple bonded oxygen is going to be a +1. So the preferred structure is this middle one here with the 2 double bonds. So the preferred structure for carbon dioxide is C double bond O with my 4 lone pair electrons, double bond on each oxygen. This is my preferred structure. These we would ignore. So although it seems like carbon would exhibit resonance, it doesn't because these two structures are not preferred. They're not stable enough, so to speak. So this would be my stable and preferred structure.